midpoint, I knew that was a review for y'all. I knew you talked about midpoint in Algebra 1. Simplifying radicals, I'm not sure. I don't know if y'all have talked about this before in Algebra 1 or in intermediate. So I'm going to treat it like we haven't. And if you have, great, it'll be a little easier for you. Okay, but the first thing we need to identify are the parts of a radical expression. So the actual radical, when you hear that word radical, that's this symbol. If my pen will work, here we go. This symbol here, that's the radical. Oh my gosh, my pen is going to drive you nuts. Okay, so that's the radical symbol. Now, the majority of the time when we're working with radicals, we're going to be doing square root. Okay, that's what's most common, that if you have done them before, you've done square root. Okay, but technically, a radical can have a different index. That in up there, that is the index. So when I refer to the index of the radical, you'll know what I'm talking about. Okay, now, all of these examples down here, except for the very last one, don't have an index. The only one that has an index written is number 8. It has a 3 there. That means that this is a cube root or a third root. If there is no index written, that is a square root. Okay, so it's understood to be a 2 for the index if nothing's written. Okay, but if it's something other than a square root, it's going to have a number there, and it'll be a third root, fourth root, fifth root, etc. Okay, so that's the index, and it's written there in the corner, like a small little digit or number. Okay, now what is under the radical symbol, in this case x, that is called your radicand. Radicand. Okay, that's what's under the radical. Okay, so now when I say index, radical, radicand, you'll know what I'm talking about. You'll often refer to radicals as the root. Okay, so you'll hear me say root. That's the same thing as radical here. All right, now what we are doing today are simplifying radicals. So yes, you could simply go plug this into Desmos and it's going to give you a decimal answer. But we don't want our answer as a decimal. We want an exact value in simplified radical form. So that's what we're going to practice and learn how to do. Okay, now, really quickly, flip over to the back. The back is blank. Okay, I'm going to put a list of perfect squares, because some people in my last class were like, I forgot, how do I know if it's a perfect square? So we're going to refresh on what perfect squares are. And if you are asked to round, okay, as a reminder, if you need to write this down, write the first place to the right of the decimal, that's the 10th. So if you're told to round to the nearest 10th, you're going one place after the decimal. Okay, and then it's hundredth and then thousandth. You always look one past what you're rounding to see if it's 5 or higher. If the number to the right of what you're rounding to is a 5 or higher, we're going to round this up. Okay, if it's 1, 2, 3, or 4, or a 0, okay, you don't round. Okay, so you always look to the right and ask, do we round? Okay, if it's a 5 or higher, you do. Feel okay about rounding? If there are instructions for rounding, you need to make sure you're going to the right place value. All right, now back to the perfect squares. So perfect squares are the values we get when we multiply some number by itself, when we square a number. So what is 1 times 1? What is 2 times 2? What is 3 times 3? Okay, what is 4 times 4? 5 times 5? 6 times 6? 7 times 7? 8 times 8? 9 times 9? 10 times 10. Now you can go past 100. I'm just going to list 1 through 10 squared. Okay, so these on the right, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. That's what I'm talking about when I say perfect squares. And of course, that does go higher. So if you want to extend your list and have your list keep going to like 15 or 20 or whatever, more power to you. Okay, but these are perfect squares. Perfect squares are values that we can take the square root of and get an integer answer. Okay, not a decimal. Okay, so the square root of 36 is 6. The square root of 49 is 7, right? Y'all understand this, what perfect squares are? Okay, so let's go back then to the front and talk about the process of simplifying a radical. What you are going to do is you are going to create a factor tree. Okay, I need the side conversations to stop. Thank you. Okay, a factor tree, we make little branches and we break down the numbers into factors. Remember, factors are numbers that multiply to give you that value. Okay, so you break it down with a factor tree and you can continue your factor tree until all your branches are prime numbers. Okay, so what is a prime number? Yeah, a number that only the only factors are 1 in itself. So 2 is prime because the only thing that will multiply to 2 is 1 times 2. Okay, 5 is prime. Okay, you can think of other examples. 13 is prime. Okay, so you just break down your factors until you have all prime numbers. Okay, so that's one method. Okay, so let's do that first step with number 1. So I'm going to break down 72 into factors. When I say branches, I just do something like that. What multiplies, and it doesn't have to be a certain set of factors. Anything that multiply, anything other than 1 and 72. Okay, so some factors of 72. Okay, so I could break it down to 8 times 9. Are either of those prime? No, I can break both of those down further. So I'm going to break down the 8. What times what is 8? Okay, 4 can break down. Now 2 is prime, isn't it? So the 2's are done. I stop at the 2's. Okay, the 9 can keep going. What are the factors of 9? 3 times 3. Okay, so now I've got all prime numbers. Okay, none of these can go any further. So what this means, you're not going to have to write this every time, but for the sake of your notes, I'm showing you what it is. Okay, so what this means is I could rewrite the square root of 72 as the square root of 22233. Okay, so 2 times 2 times 2 times 3 times 3. So I'm just breaking it down into its prime factors. Then it says you're going to find any pairs because we're doing square root. We're looking for pairs. Now, if your index was 3, like this last one, you're not going to look for pairs. You're going to look for triples. You're going to look for 3 of a kind. Okay, but since this is a square root, we're looking for pairs. So any pairs. So I'm going to circle my pairs. So there's a pair of 2's. There's a pair of 3's. This other 2, he doesn't have a pair or a partner. He's all by himself, all by his lonesome. Now, the ones with a partner or a pair are going to get to come outside the radical. So a 2 gets to come out and a 3 gets to come out. But that other 2 that didn't have a pair has to stay inside. Okay, so those with a pair get to come out. So pairs come outside. Okay, so the number that has a pair gets to come outside the radical. Okay, leave any other factors under the radical. Then it says to simplify, So if there's multiple terms inside or outside, you go ahead and multiply those factors. So what is 2 times 3? And there's nothing to multiply that other 2 by, so it just stays. So this is 6 root 2. Okay, that is the simplified radical for square root of 72. Now, like I said, you're not going to have that line where I wrote all of those prime factors under the radical. You don't have to do that. Thank you. Just on top is the notes, the far left stack on top. That's today's outline. Yeah. Should be 1.7. Yeah. Okay. So some of you, instead of listing it out like this every time, you're just going to look at your tree and you're going to find your pairs there. You're going to say, oh, there's a pair of 3s. Now, I want you to understand, your pair of 2s don't have to be next to each other like this. This could be a pair of 2s. Oops. That could be a pair of 2s. It doesn't matter as long as there's 2 of them. They don't have to be side by side to be a pair. Do you get that? Okay. So now, there is a special case under here that says if you have perfect square factors, okay, or whatever your index is, if it's a cube, perfect cube factors, but we're doing square root for the majority of these, so we're looking for perfect square factors. So if you end up with any perfect square factors, okay, you can stop your branch there. You don't have to keep going until it's prime numbers. Okay, so let's look at number 2. Let's see what happens here. What's factors of 50? 25. Okay, I heard 25 and 2, and I also heard 5 and 10. So I'm going to show you both work, and I'm going to show you what is different depending on which way you pick. So if I picked 5 and 10, 5 is prime, but 10 I can break down further to 2 and 5, right? Now those are all prime. So I can do this like the last one where I've broken this down to all prime factors. And then I look for a pair. Are there any pairs? Yeah, the 5s, right? So a 5 gets to come out, but that 2, he's by himself, he has to stay inside. So I have 5 root 2, and there's nothing to simplify. There's only one factor inside and one factor outside. So that's it. It's 5 root 2. However, if I chose the perfect square factor of 25 and 2, I could stop there at 25 because I know this is breaking down to the square root, right? If I were to rewrite this, it'd be the square root of 25 times 2. Okay, and what is the square root of 25? So because it's a perfect square, I can just stop there and say, oh, that's going to be a 5 on the outside and a 2 on the inside. Okay, so you can keep going until they're all prime numbers like these first 2. Or if there is a perfect square factor, okay, it shortens up your work, your branches. You don't have to go as far with your tree. Does that make sense? Kind of, sort of? Okay, let's try number 3. Okay, what are some facts? Let's try and ask ourselves, is there a perfect square factor? So that list of perfect squares on the back, is 48 divisible by any of these perfect squares? It is. What 48 could be divided by a couple of these? Which ones? It could be divided by 4. Could it be divided by a bigger one? 16, right? Are y'all, oops, I didn't mean to go there. Okay, so if you are unsure, you can always use your calculator and check. Okay, so just type in 48 divided by and see, check if it's divisible by any of those perfect squares. So this one is divisible by 16. That's the largest perfect square it's divisible by. It would be 16 times 3. And now because that's a perfect square, I can stop my tree and just say, okay, the square root of 16 is what? It's 4. So this is just 4 root 3. Now, there are on Delta Math some guided questions that are trying to break the process down for you. You only have to do 2 of the guided, and then you're just going to do some other practice however you want. But in the guided practice, it has you break it down like this. It says, okay, this is square root of 16 times square root of 3. And then it says, okay, square root of 16, that's the 4, and then that's still the 3. So that's how it's having you write each, like you have to do each little step. Okay. For the sake of our notes, you don't have to write that every time, but that's where the 4 is coming from, because we just broke down square root of 48 to square root of 16 times square root of 3. And then the square root of 16 is 4. And the square root of 3, we can't break down any further. So that's it. Does that make sense? Okay. All right. Is there a perfect square factor of 32? Also 16. 16 times 2. So since 16 is a perfect square, okay, what is this going to be? 4 root 2. Okay, now again, if you struggle finding the perfect square factor, you don't have to do it this way. You can take it all the way to the prime numbers or till you get pairs. Okay, so let me just show you. When you originally saw square root of 32, if you didn't think of 16 and 2, what did you think of? What other factors of 32 would pop into your head? 8 and 4. Okay, now 4 is also a perfect square, isn't it? Okay, so you technically could stop there and just keep going with your 8. Now, you see a pair already. Even though those could keep going, I see a pair. So once I see a pair, I could stop and say, oh, a 4 is going to get to come out because it has a partner. And then that 2 is going to have to stay underneath. And I got the same thing, didn't I? Okay. Or if I took those 4s further to 2 and 2 and 2 and 2, it'd be like this first one where I had 2 pairs and I'd take one out from each of those and have to simplify. I could do it that way as well. So how you break it down might vary person to person. Okay, and that's okay. You get the same answer in the end. Okay, let's start factors of 80.
10 and 8.
10 and 8. Okay, factors of, I don't know why I'm writing that. Factors of 10.
2.
Factors of 8.
4 and 2.
Factors of 4. 2 times 2. So if I didn't stop when I saw the 4, it's okay. I can break it down to 2 and 2. Now, how many pairs do you see? I see a pair of 2s here and a pair of 2s here. Because remember, I broke all of these down to my prime numbers. The pairs do not have to be next to each other like this bottom one. See how these are on 2 different branches? That's okay. They're the same number, so they're a pair. So that means that a 2 gets to come out from one pair and a 2 from the second pair, and the 5 has to stay underneath. And then I multiply. What's 2 times 2? Guys, stick with me. 75. Break it down. 5 and 25? Not 5 and 25. 3 and 25. Okay. Or some of y'all did 5 and 15. I just wrote it again, y'all. I would do this one because this is a perfect square. So I know the square root of 25 is 5, and then just the 3 is left underneath. Okay, if you chose a different pair of factors and did it differently, as long as you ended up with 5 root 3, that's correct. All right, now 7 and 9 or 7 and 8 are slightly different. Okay, 7 is different because let's see what happens. What are the factors of some factors of 225? Okay, so 25 and 9. Okay, you could either stop, guys, please stop the side conversations. We're almost done. Thank you. You could stop here because both of those are perfect squares, right? So I could take out a 5 and a 3 because that's the square root of 25 and 9. But if you don't realize that, it's okay. You could take it a step further and you would break this down to 5 and 5 and 3 and 3. And you would see, oh, there's a pair of 3s and a pair of 5s. So a 5 gets to come out and a 3 gets to come out, whether you stopped here on this step or you took it a step further and went here. Either way, it's a 5 and a 3 that come out, correct? Now, once that 5 and that 3 come out, is there anything left under the radical? No, so the radical's gone. You don't write it if there's nothing to put under it, okay? Because it's technically just a 1 left under there, and the square root of 1's just 1. We don't have to write multiplied by 1 because that doesn't change anything, does it? So it's just 5 times 3, which is, so this 225 is a what? It's a perfect square. The square root of 225 is 15. So if you knew the perfect squares, you could just answer it. But if you don't, you break it down and you still get it. Make sense? Okay. Now, 8, I just want to challenge you a little. What if it's not a square root? This is a cube root or a third root. So we're still going to make our factor tree the same way, but instead of looking for pairs, like we set up here, find any pairs or whatever your index is. My index this time is a 3, so I'm looking for 3 of a kind once I have my factors. Okay, so what are some factors of 250? Okay, now I would not stop here with the 25 since it's a perfect square because I'm not doing square root, I'm doing cube root. So I have to keep going with that 25. That would be 5 times 5. And the 10 would be 5 times 2. Now, all of those are prime numbers, right? And I'm looking for 3 of a kind or a triple. Are there 3 of the same number there? And I'm looking for 3 of the same number because it's a cube root. So that means a 5 gets to come out because there's a triple or a 3 of a kind, and a 2 stays underneath. So this would just be, hang on, I just messed up there. It's not root, it's not square root. What is it? Cube root. We need to have the index of a 3 there. So cube root 2. Does that make sense? Okay, so your practice, I'm going to just show you one of the guided that I'm talking about because people last class were getting a little confused. Okay, so it's linked here. You should be able to open it in a new window when you hit load. So let me show you. Here are the types of questions. So this one with the little clock next to it is a timed question. This is just practicing your perfect squares and square roots, and you keep going till you can get the correct number in the set time, okay? Now, these simplifying radicals, the last one, you can do your factor tree however you want, because you're not having to show work, you're just having to give the simplified radical answer at the end, okay? But the guided is having to do it a certain way. So I'm going to walk you through one so you understand the process. They want you to go step by step, and it doesn't say, but it wants you to start with perfect square factors. So it doesn't want you to just pick any random factors of 112. It wants you to use perfect square factors. So if you don't know it, you could, in your calculator, you could just type in, okay, 112 divided by, and then check some of your perfect squares. Like 4, hey, that divided evenly. So 4 is a factor. So 4 and 28. So I would come over here and I would type in, and go back to my 4 and 28. If you hit try and it takes you to the next step, you're good. If it's not a perfect square factor in one of those, it's going to give you a little message and tell you that it's not, and it's going to have you go back and try again. Now, what is the square root of 4?
2 and 2.
So just 2. Because once it's not under the radical, it's just a 2, right? So now it's just a 2 outside, and it's still the 28 inside. And now it's going to have us break the 28 down further. Is there a perfect square factor of 28? Four and what? 4 and 7. So the 4, again, square root of 4 would come out as a 2, and then the 7 would still be underneath. Now they want you to simplify. What's 2 times 2 out here? So a 4 on the outside and a 7 on the inside. And once you get here, that's it. And you just hit submit. And that's correct. Okay. Now, look, they did a different path. There was a faster path. 16 was also a factor. So you could have done it that way. But as long as you're pulling out a perfect square factor, it's going to let you do it that way. So that's how the guided one works. So I'm going to leave this one worked out like step by step so you can see what it's asking you to do. You only have to do 2 of the guided, and then you're good to do the other ones however you want. Okay. So let me stop this recording. Okay. And everybody should be working, and you can talk to each other. You can use your notes. You can ask me questions.